So, so this is your note actually. Okay. So in first phase, here there is a picture. Okay, that which tells you how much signals are important. Okay, in our with our stuff. Okay, so you can see that this is a simple communication system. Okay, it's a simple communication system. Okay, so you can see that the person is speaking to a microphone. Okay, so this is transducer. Transducer means sensor. Okay, so so transducer means converting one some signal into another signal. Most probably it is an electrical signal. Okay, so another word for this transducer is a sensor. Okay, so transducer is a sensor. Okay, so this transducer convert the audio is the words or the sound, actually sound. Okay, so this transducer is converting the sound into a electrical signal. Okay, so here at the output of the transducer, so this transducer is nothing but it is a microphone. Okay, so at the output of the microphone we will get the electrical signal. So here we are dealing with the signal. Okay, now before before transmitting that voice, we have to do some processing. Okay, so sometimes we have to convert. So this is an analog signal. Okay, continuous signal. Okay, so sometimes we have to convert it to a digital signal. Okay, then we have to do other processing, like we have to compress the information, and we have to add some additional information like error correction, error detection, like such information. Then so there are some processing here, and then that signal is fed to the transmitter. Okay. So transmitter will transmit the signal. Okay, so if this transmitter is a wireless transmitter. Okay, so there should be an antenna. No? So we have to feed our signal to the antenna, and antenna will propagate a wave, electromagnetic wave. So definitely this will be a wireless transmitter, because here the electromagnetic wave is propagating, electromagnetic wave is sending. Okay, then at the receiver we receive the wave, and then that receiver, that antenna will generate an electrical signal. Okay, then electrical signal we have to do some processing, and then we have to feed it to another transducer. So this also a sensor. That sensor should be, so anyone can tell what is this? What is this transducer? What is this transducer is doing? Please tell someone. So try to talk with me. So it is good for you actually. Okay, if the answer is correct or wrong, it is okay, no issue. But if you are talking with me, that is good for your skills. Okay, skills development. So please talk with me. So what is this transducer doing? What is this actually? So I need the feedback. So can you hear me? Someone please tell, what is this? What is this component? Yes. What is this component? Please tell someone. Don't. Yeah, it is a sound output device. And what is that actually? Pramod, thank you for your answer. Okay. So I like if you can talk with me. It is a sound output device. Actually, what is that? It is a name. There is a name for that. Yeah, it is a speaker. So this is a speaker, no? So what is this speaker doing? So here the input to the speaker is the electrical signal, and we can get output sound signal. So that both answers are correct. Okay. So this is the speaker. So you can see that this is a very simple fundamental communication system, but at many stage we have to deal with signals. Okay. So 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 this is the importance of signals. And why system? Okay. So what are the systems here? So if you can consider, if you can think, this whole uh, process is a system. Okay, this whole process is a system actually. Okay, so here you input something and you get the output. Okay, so that is a system. Okay, still we are not talking about the system. We are still talking about signals. Okay, so always signals are related with systems. Okay, so this whole process is a system actually. Okay. So if you consider one by one, if this transducer, if you consider this transducer, so we have a input and we have output. So it is also a system, okay? Because we have an input and we have output signal, okay? So this is also a system. And if you consider this transmitter, it is also a system, okay? We have input and output. So this receiver also is a system. This transducer, this speaker is also a system, okay? So you can see that in this fundamental communication system, we have many related signals and many related systems. Okay. So this diagram is to give you an idea how why signals and systems are very important for our engineering life. Okay. So here we have some definitions about signals. Okay. So so we have already talked that signal is a function. No? So we can represent a signal as a function of two variables. Okay. So most probably our independent variable will be time, and our dependent variable will be a current or voltage or maybe a power. Okay, with our electronics and electrical stuff. So if you are a mechanical engineer, it may be a force. Okay, it may be a force, or it may be a pressure or something. Okay, so it can be any quantity. Okay, any quantity represents some information. Okay, so this is another definition. Okay, so we are mainly dealing with, so We are electronics and electrical students, communication students. You are. So we are mainly dealing with voltage, current, and power is not force. Okay, not pressure, not momentum. Okay, not with the speed. Okay, so you can see that the time, and here we plot the time versus a speed of a car. Okay, or it may be a distance of a car. So actually it is a speed of a car, velocity of a car. So it is also a signal. Okay. So I think you have already got the idea what is signal. Okay, and here now we are coming to the signal classification. Okay, can you remember that we are talking about signal classification? So here we have continuous and discrete signal. So here they have plotted. Okay, continuous and time is a continuous signal, and this is a discrete signal. Okay, and this is how it mathematically represent. Okay, so now I think this part, this discrete representation, you no need to worry about. Okay, but this representation we have to deal with this representation at this time. Okay, and also this is a graphical representation of a signal. So this is a sinusoidal waveform. Okay, so I have described a sinusoidal waveform. Please go through that video and try to understand. Okay, what you all have to understand is the pattern and how the time and these amplitudes are related. Okay, so we will do some example here. Okay, today we will try to do some example. Okay, then you can you can get a good idea about that. So here also we have random and deterministic signal. Okay, we didn't talk about this. Okay, but I think we are now actually we are dealing with deterministic signal in our course. Okay, we are not going to dealing with we are not going to deal with random signal. We are only dealing with deterministic signals. Okay, so deterministic signals means it is not so how to say, it is varying with according to time. Okay, but it is a constant value. Okay, it is a certain value. Okay, but so here it is defined here, there is no uncertainty. Okay, so it is a certain value there. So it may be varying with time. Okay, so sinusoidal signal is varying with time, no? So if you plot it again, the sine signal is same. Okay, if you plot it and plot it again, you will get the same sinusoidal signal. But random signal, it is not like that. If you plot, it is this time. Okay, it is in another. It is when you are going to plot it next time, the pattern may be changed. Okay, so that is a random signal. Okay, so here we have talked about the periodic and non-periodic signal, aperiodic signals. Okay, we have discussed about this property. Okay, so at this time you no need to worry about this property. Okay, this is for discrete time signal. Okay, you have to deal with only this continuous time signal condition. Okay, so here we have exercise, please try to do it. Okay, and we have even and odd signal. Still we are not discussing this. Okay, here I am not going to discuss it. Okay, and we have another energy and power signal. Okay, I'm not going to discuss here this. Okay, so I have Actually, I have missed this two slides. Okay, miss this 9, 10, 11 slides. Okay, and I jump to this slide. Okay, so here we are going to talk about the basic signals. Okay, so one of basic signal is a sinusoidal signal. Already I have discussed it. Okay, so you can go through that video and please watch it and try to get the idea. Okay, and other things we have to discuss. Okay, still we are not still we have not discussed this stuff. Okay, so only we have discussed up to here. Okay, up to here, up to this special function that is a sinusoidal signal. Okay, so ඔකට මොනවද ප්‍රශ්න තියෙනවද ඒ ටිකේ? ඒක අර කලින් කරපු ටිකමයි මම ආපහු කීවේ. ඒ වගේ මොන හරි ප්‍රශ්නයක් තියෙනවද? තේරුම් නැති තැනක් එහෙම තියෙනවද? කියන්නේ තේරුම් නැති තැනක් ඔක්කොම වගේ තේරෙලා නැහැ වගේ මේකක්ද තියෙන්නේ? හරි කමන්නේ. සමහරට තාම ඔය කට්ටියට ප්‍රශ්නයක් අහන්න තරම් සබ්ජෙක්ට් එක තේරෙලා නැතුව ඇති. හරි? හරි. අපි බලමු අපි මම කියනවා ඔය කට්ටියට අර සයිනසෝඩියල් සිග්නල් එක මේ ගැන කරා කියලා. Okay, please go through that video and get idea. Okay, so we know that. So I hope you can see my screen. No, you can see my writing. Can you see my writing? Can you see? Please feedback. Yeah, thank you. India. Okay, so so this is the form of a sinusoidal signal. Okay, yt is equal to a sine 5 ft plus theta. Okay, so this is the sine wave. This is a sinusoidal wave. Sinusoidal wave. Okay. Okay. So so I think you have learned some trigonometric stuff, no, in your mathematics. So do you guys have learned this identity? Sine theta by phi 2 is equal to cos theta. Do you know this identity? So I hope you have learned this. Can you feedback? Have you learned this trigonometric identity? Can someone feedback? Yeah, so anyway, so there is a trigonometric identity like this. Okay, so if you get sine theta plus 5/2, so this 5/2 is you know, it is 90 degree, no? So this is in radians, And if you convert that radians, so this is, sorry, this is for radians. Okay. You know that 5 by 2 radians is equal to 90 degree. No? Okay. So sine theta plus 90 is equal to cos theta. Okay. So I think okay, we will go some waveform, then you can get the idea. Okay. Okay. So anyway, what I want to tell you is that if you convert this phase shift, I can see that these are very so anyway, we have to deal with, we have to go through this. Okay. So so what I want to tell is that, so can anyone tell what is this and what is this and what is this? Can anyone tell what is this? What is we call this? So I have explained it in my video. Okay. So if you have seen that video, maybe you know. So what is this? Is feedback someone? If the answer is wrong, it is okay. Can someone feedback? What is that? Yeah, Paridu, thank you. It is a peak value. Okay, there is a name. Can you remember that name? It is a peak value. Good, okay. Sorry, Parinja. Good. Okay, it is the peak value. Can you remember the name for that? Yeah, that is a peak value. That's correct. Okay, it is the peak value. But we called it what? Amplitude. So this is the amplitude. Can you remember? This is amplitude. Okay, and can please tell someone what is this? What is this F? What is that? Give me a moment. Give me a moment. Yes, thank you. That is the frequency. Okay, so that is the frequency. So this is the frequency. And what is this? What is this T? What is this? We call this phase shift, no? This is the phase shift. So these three parameters are the most important parameters for a sine wave. Actually, we can determine all the information using these three parameters. Okay. So, what I want to tell you is that if this phase shift is 5/2, if this phase shift is 5/2, so this will become cosine. No? So from this identity, okay, sine theta plus 5/2 is equal to cos theta. So using that identity, we will get a sine 25 ft. Sorry, a cos 25 ft. Okay, so this is so it is a matter of this phase shift. Okay, so sometimes these sinusoidal signals are represent in a cos term. Okay, so both are sinusoidal signal. So if you have this kind of signal, okay, so this is also sinusoidal signal, and this is the amplitude, and this is the frequency, okay, and this is the phase shift. Okay, so so it may be a sine or it may be a cos. Okay, both are sinusoidal signal. You can see that the cos and sine can interchange with this theta value. Okay, theta value. So that is the only thing you have to understand. Okay, so I have get some relationship between this frequency and time and period and other things. Okay, so if you draw this signal, so we will get a signal like this. Okay, so if we have a theta, so if this theta is 0, it is a pure sine. Okay, so sine wave is like this. It is starting from 0 like this. Okay, so if this theta is 5/2, it is starting here with 1 like this. Okay, like this. Okay. So it will go like this. So this is cos. This is the cos function. It is starting from 1. That means this theta is equal to 5/2. So you can see that with this theta, changing, the starting point can be changed. Okay. So we will get, if the theta is there, so we will get this kind of signal. Okay. Because it is between 0 and within this amplitude. Okay. If it is 5/2, so it will start from this 5/2. Okay. So you have any problem with this? Should I explain it again? Please tell if anyone couldn't understand, please tell me. Signal system. Okay, Udil, I will explain it again. Okay. So you know that this is the sine signal. Okay, so this is a sine signal. I will explain it again. I will go to the next page. Okay, so you know that we will get a sine signal like this: a sine 25 ft plus theta. Okay, so this is the basic form of a sinusoidal signal. Okay, so this is the basic form of a sinusoidal signal. Sinusoidal signal. Okay. So, uh, if we plot a sine signal, okay, that means if we plot. So please go through that lecture, and it is I have explained how this theta related with how this theta is converted into a time varying function. Okay, so these things I have discussed is okay. So if I plot sine theta with respect to theta, okay, so we will have this kind of graph. So if this is sine theta, okay, so here this is sine theta. Okay, so here it will be 1. Okay, and this also will be -1. So this is the sine wave. So this is the sine graph actually. This is a sine graph. Okay. So if you plot the cos theta, okay, if you plot the cos theta, okay, so you will start from here. Okay, from 1 like this. Okay. Here it is. Here like this. We will get like this. Okay. So this is the cos theta. Okay, cos theta. So so uh, so you know that sine theta plus 5/2 is equal to cos theta. Okay. So if this is 5/2, this angle is 5/2, so it will become a cos function. Okay, so you will get this kind of graph, this kind of wave. Okay, this kind of plot. Okay, so if I consider this sine theta plus 5 or something, okay, 5 or something. Okay, so if this is 5/2, if this is 5/2, here it is starting from here. Okay, but if this is not 5/2, it is less than 5/2, you will start with here. Okay, between 0 and 1. So you will get this kind of signal. Okay? So that is what I want to tell you, that I want to show you, tell you. Okay, so I will come here again. Okay, I will come here again. So here 25ft now. Okay, so at that time I have considered this as theta. Okay, this is my angle. Okay, and this theta I have considered as 5 with respect to this one. Okay, මේකත් එක්ක compare කරලා. හරි. දැන් බලන්න මේක අඳින්න. Okay. So if I plot this, okay, if I plot this, okay, so I will get if so now this theta is a function of t. Okay, now this theta is 25ft. So you can see that these are constant. Okay, so this theta is changing with time directly. Okay, so when this theta is increasing, t is increasing, time is increasing, this theta is also increasing. Okay, it is increasing linearly. Okay, if you get 2t, so this will be 2 theta. Okay, for example, if you get 1 second, at 1 second, if the theta is 45 degree, so if you get the 2 second, you will get 90 degree. Okay, this is for example. It is increasing linearly with respect to t and theta. Okay. Okay. So, so now, I am going to plot. I instead of this theta, here I put t. It is same. Okay. So because this theta is directly related with theta. Okay. So theta is equal to 25 ft actually. Okay. So you can see that this is a constant. Okay. So this theta is directly related with this t. Okay. So instead of this theta, I put this t. So you can see that according to t, the theta is changing. The angle of the, so here it should be angle. Okay. So angle is changing. Okay. So if I consider this theta is 0, so sine wave is starting. Okay, the sine wave is starting here at 0. So it will go like this. Okay, but here there is a phase shift. Theta is there. Okay, so if this theta is pi by 2, you will get a cos signal. So it is starting here, as I told you previously. It is starting here and go like this. Okay, but now if this theta is between less than 5 by 2, okay, so here it is 0, here it is 1, you will start with this type of section like this. Okay, so this is the wave with the phase shift. Okay, so here you can see the phase shift, otherwise you will start it here 0. Okay, now this has a phase shift. Okay, so we will see this phase shift later. Okay, so at this point, try to understand at least up to this one. Okay. Okay. So I also have verified some relationship between the period and this f, this period and other things. Okay, so you know that. Okay, so if you consider sine wave, I will again write it here. Okay, so this time, this is we called one circle. Okay, for sinusoidal signal, this is we called one cycle. This is one cycle. Okay, so if this cycle time is t, capital T. Okay, so this is the period of the signal actually. Okay, this is the period of the signal. Okay, so if this is t, okay, so you can see that here with t second, one cycle is there. One cycle is there. Okay, so for 1 second, how many cycle is there? 1 by t. Okay, so cycle per second, there is a name. What is that? Cycle per second, we called it frequency. If, okay, so there is a relationship between this cycle duration, that is we call period, okay, and period and f. So this is one identity. 1 by t is equal to f. Okay, so you should remember this identity. Okay, so this is one important equation. Okay, this one. Okay, another thing is, so I have explained this all these things in the previous lecture, so you can refer this. Okay, and we have another one. we called it omega, and we called it angular frequency. Angular frequency. Angular frequency, or sometime angular velocity. Most probably it is angular frequency. We called it angular frequency. Okay. So this omega can be defined as 2πf. Okay. So this omega can be defined as 2πf. In other words, if this f is 1 by t, also we can define omega as 2π by t. Okay. So what is this actually? Okay. So in another words, okay, please go through that video, then sometime you may understand. Okay. So this 2π is actually the total degree traveling, total degree. Okay. And this is the time for total degree. Okay. So this is a degree, some distance actually. So this is a time. So it is a velocity, no, it is a speed. So that is, we called it velocity. Okay. Angular velocity. Okay. Anyway, you have to remember this identity. Okay. So I have tell it again. One is f is equal to 1 by t, this one, and omega angular frequency. So this is angular frequency. Angular frequency. It is 2πf. Okay. And omega also we can write as 2πt. So you have to keep remember these three identity. Okay. This is one, this is two, this is three. These three identity you should keep remember. This is strictly for sinusoidal signal. Okay. This is for sinusoidal signal. Okay. So actually, I have discussed how this can be derived, or how we can get this identity in a previous lecture. Please refer that and try to get a good understanding. Okay. So at least you have to keep them in your mind. Okay. If you couldn't understand the relationship very well, at least you have to keep in mind. Okay. So we will do one exercise. Okay. We will do an exercise. So actually this is your assignment. Okay. So you have to submit this. Okay. You have to answer the question and you have to submit it. So I hope it is very, only 5 questions are there. Okay. Only 6 questions are there. Okay. So this is already, you know, what is a signal and how can we classify the signal with respect to its behavior. And please give some example. Let us say you have to explain the continuous and discrete time signal, explain periodic and non-periodic signal. So here you have to mention the condition. Okay. So now we will go to this question. Okay. So I will not going to do the exact question. I will do the similar one. Okay. Then you can do this question by yourself. Okay. And send it to me. Okay. So you can, yeah, it should be 2. Okay. This is not 2. It should be 2. It should be 2. Okay. This is 2. two AC turbines generate sinusoidal AC signal. Okay. So normally we called if the voltage is alternating, we called it AC voltage. Okay, AC voltage. And if we have a direct voltage, we normally call it DC voltage. No? So this AC means alternative current. Okay, but anyway we refer it as AC voltage and DC voltage. Sometimes it is ACV and sometimes denote it DCV. Okay, so these are some day-to-day usage. Okay, so in day-to-day life we are using these terms for DC and AC voltages. Okay, so this is AC voltage. Okay, so you can see that it is generating a sinusoidal signal. Okay, so here you can see that sinusoidal signal is given in terms of cos. Okay, so now you know that it is doesn't matter, no, it can be sine or cos. Okay, so only thing is this theta will be changing, this phase shift. Okay, but it also sinusoidal signal, sine signal with different phase. Okay, the sine signal is pure sine signal is like this, not pure sine signal. Zero phase shifted sine signal is like this. So if it is cos with some theta, so it may be like this. Okay, so again it is a sinusoidal signal with different phase. Okay, it should be start from zero, but now it is start from another point. So that is the things you have to understand. If this is cos or sine, it is not matter. Okay, so this is a sine, this is a cos. Okay, so you have to draw these signals. Okay, so I will go. Okay, so let's take. Okay, so we have our voltage signal. It is like that, a sine 5 ft plus theta. Okay, sorry, this is cos. Okay, cos 5 ft theta. Okay. So let's take that. Let's take that A is equal to 2 volt, F is equal to 50 hertz. Okay, 50 hertz, and theta is equal to first we will consider 0. Okay, so can you draw this waveform? Please try to get some times. Okay, so this is like this. Okay, so you know that so if you want to find the t, okay, if you want to find the t, this t, you have f. Okay, you have f, and using f you can find the t. That is for one circle. This is for one circle. Okay, so can you draw this? This is T and this is VT, voltage. Can you try to do this? So I will give you 5 minutes. Try to draw this. Then I will try. I will draw. Then you can compare your one and my one. Okay. So please get 5 minutes and try to draw this signal. Hello, so did anyone try this? Okay, we will see. We will see how we can draw this. Okay, so first thing is, so you can see that this theta is equal to 0. No? This theta is equal to 0. So you will get this kind of. So if I write it here, okay, with our given parameter, I have write it here. Okay, so I will get Vt is equal to, so A is equal to 2 volt, so it is 2. Okay, so we have cos 2, 5, so here it is 50. Okay, phase 50 hertz. Okay, 50 hertz E plus 0. 0 means there is no value, no? Okay, so you can see that this is a cos signal. This is a cos signal. Okay, so if this theta t is 0, so you will have cos 0. Okay, so we have seen that cos 0 is equal to 1. I have told you that if it is a cos signal, so we will start at 1. Okay, at 1, like this. So in your examination, so you will get to draw this kind of sinusoidal signal maybe. Okay, so I have seen that in some examination, you are given to draw this kind of signals. Okay, so mm, Okay, I will get a sine signal here. Okay, because I have only explained how we get the sine signal here. Sine signal. There I have explained why, how sine theta is equal to 1, how sine 0 is equal to 0, how sine pi by 2 is equal to 1. This is stuff I have explained. Okay, so I will use that type of signal. Okay, we will do later for cos terms. Okay, so here I will get sine. Okay, and this tutorial also, please convert this to sine. Okay, don't get cos terms, please get the sine term. Okay, so uh, so it is a sine 5 by 2550t. Okay, 2550t. So anyone has a problem why I get this sign? Are you confused? Don't be confused. Okay, I just get sine because I have explained the sine graph in my previous lectures, which I have uploaded to the LMS. Okay, so so I will get the sine, because otherwise you will get confused. If I get the cos here, if you watch that video, then you will get confused. That is why I get the sine value. So later we can go for a cos signal, but I think it is better to start with the sine signal. Okay, that is why I take sine as a start. Okay, are you have any confused? I hope you have no any confusion. Okay, so I will proceed. Okay, so now I'm going to draw a sine signal here. Okay, so here we have t. Okay, so here I have vt. Okay, so you know that this is my signal. Okay, vt 2 sine 25 ft. Okay, so you know that, so sine t is equal to 0 when t is equal to 0. Okay, when t is equal to 0, sine it will be sine 0. Okay, it will be sine 0. Okay, so sine 0 is 0. Okay, I have explained this. Sine 0 is 0. So it is starting here. Okay, so I'm starting here, and so when, so here, so we will have, so we will have this kind of signal. Okay, but we have to mark the corresponding value. Okay, so you know that this value. Okay, you know that this value. What is this value? This is the amplitude, no? So it is this 2. Okay, so here we have +2 and here we have -2. That is okay. So so how we find this important section? I think this section is important. This point is very important, and this point is very important. So at least we have to mark this point, this point, this point, and this point. So how you can find the corresponding time for this point? So you know that this point is time 0. So you have already figured out that point. It is 0. And you have to measure this one, you have to calculate this one, and you have to calculate this one, and you have to calculate this one. Okay. So how we can calculate it? Okay. So I think the easiest way is we can calculate this whole value. Okay, so what is this whole value? It is t. It is t. Okay, so I think you can calculate the t. Okay, please someone calculate the capital T and tell me what is the answer. Please someone calculate it. Please tell me the answer. 2 minutes. What is the capital T? Yeah, Kusumi, thank you. So I think it is pointer 002. How you can find it? So capital T is equal to 1 by F, no? 1 by F. 1 by F. Okay. Capital T is equal to 1 by F. So 1 by F means 1 by 50. 50 hertz. So it is 1 by 50 hertz. Okay. So we will get, due to this hertz, we will get the answer from time, answer from second. Okay. So we will get 0.02. Yeah, 0.0. So this T is 0.02. So here this point is 0.0. Okay. Then you know that. So this is a one circle. This is a one circle. Okay. So this is a half of a circle. Okay. So if this is a half of a circle, so you will get half of one circle time. No? So here you will get 0.001. Okay. And this is a half circle. Okay. When I explain you that, you can see that this is a quarter circle. Okay. This is a quarter circle up to here. So you will get half of this one. That means 0.005. Okay. So what is this point? Can anyone tell this point, this time point? I will write, I will type it here again. Okay. So here we have this point. We have 0.005. This point we have 0.001. This point we have 0.02 second. Okay, or last second. This time is measured in second. This voltage is measured in volt. Okay. So what is this point? Please tell someone. Yeah. Thank you, Nimal. Okay. This is actually, so here this should be another quarter, no? From here to here, it is another quarter. Okay. So I have, you can see that I have explained it with the circle like this. Okay. And this participle is moving along this circle. Okay. We have, yeah, yeah, Oshan. Yeah, thank you. Okay. So you can see that from at this point it is 0. Okay. From here to here, so it means 5 by 2, 5 by 2 theta. Okay. At that time, the point is here. So it is the maximum. Okay. You can see that previous lecture, then you can understand. Okay. So from here to here, okay. So from here to here, you will complete this circle from here to here. And from here to here, okay, here to here, you will complete this circle. Okay. And from here to here, okay, here to here, you will complete this part. Okay. That means this is one quarter. This is one quarter. So it will have 0.005. This is another quarter. That means again it is has 0.05. So at this point it is 0.01. So here another quarter, it will take another 0.05. So you will get 0.015 at this point. Okay. So your answer is correct. It is 0.015. Okay. So actually this is the graph. Other things also same like this. Okay. So do you have, did you get the idea how to draw that line? Okay. So anyway, we will draw the next one also. I will draw the next one. Okay. So here we have VT, the next one. Okay. What is the next one? So here it is 5/3. Okay. But I didn't get 5/3. I will get another value. Okay. So I will get, so this is our signal A sine 5 ft plus beta. So at this point I will get, so the previously we will get 2 as 2 volt, A as 2 volt, F as 50 hertz, and theta as 0. So at this time I will get A as 3 volt, okay, F as 100 hertz, and theta as 5/4. Okay. So if I write my signal with these parameters, so we will get Vt is equal to 3 sine 25f t plus 5/4. Okay. So we will have this signal 5/4. Then we have to draw. So how to draw it? So first thing is you can put theta. So this is t. Okay. This is sine 5t plus 5/4. Okay. So that is Vt. That is Vt. Okay. So this is Vt. So how to draw this? So we have to find the starting point here. Okay. So t is at 0. Now we begin t is at 0. Okay. So if t is 0, if t is 0, t is 0. So what you will get? You will get, if t is 0, 3 sine, this terms will be 0. No? If t is 0, this term will be 0, and you will get sine 5/4. Okay. So this at this 0, you will get the value here, 3 sine 5/4. Okay. So you can use a calculator and find this value. Okay. So you have to type sine 5/4, then you will get some value here. Okay. So that is the starting value. Okay. So please calculate this value and tell me what is this. Okay. So it is start here. Okay. So now it is repeating. It will repeating like this, no? It's repeating like this. Okay. So then, how to find this peak value? Say this is 3, and say this is 3. Okay. So you have to find this peak value. How to find this peak value? Okay. So So at the peak value, you have to find this t. So can one suggest any method to find this t? Any method to find this t? Can someone suggest? So if you get 1 by t is equal to f, so using f, you can get the t, no? So you can get the t. So it will be, what is the t value here? Yeah, 0.01. Okay. So here this t value is 0.01, but it will not help you, no? Because this here the phase shift is changing, but you can't find. Okay. So that t is, I think from here to here, that t is you can apply. From here to here, that t is there. Okay. But here you can't exactly identify the point. Okay. So you have to find another way. Okay. So that is okay. So if you have seen my video, maybe you can get idea. Okay. So you can see that first peak we have to come when that circle, if you if you have seen that, without seeing this you may get confusion with this circle. Okay. But sinusoidal signal is defining using this circle normally. Okay. So when this part is come to here, this object, this participle is come to here, we will get the peak point. Okay, peak point. At the peak point, we will have 5 by 2 degree. Okay. So at the peak point, at the peak point, okay, at the peak point, this should be 5 by 2. All this term should be 5 by 2. Okay. So 5 by 2 is equal to 25 ft plus 5 by 4. Okay. So using this, so now you have a simple equation. So you can find t here. So you know f, it is 100. Okay. Now you can find t. Okay. So anyone, I think you couldn't understand this one. Am I right? Any problem with this identity? Okay. So only thing you should know is that when sine 5 by 2, it is equal to 1. Okay. That means at 5 by 2, at 5 by 2, the theta is equal to 5 by 2, we get the maximum peak value. Peak value. We get the peak value at 5 by 2. So, so we need to get this peak value, first peak value. So this peak value should get with 5 by 2. Okay. So you can see that if we get this whole angle is 5 by 2, then at that point we will get the peak point. No? So for example, if Vt is 3 sine 5 by 2, you will get 3, this value, 3 volt, this value. Okay. So if you compare, if you equal this whole angle to 5 by 2, then you can find the t, corresponding t. So what is that t? What is that t? So this 5, 5, 5 cancel out. Okay. So we have half 2, f is 100, that means 200 t plus 1 by 4. Okay, so you will have 200t is equal to 1 by 4 minus 1 by 2 minus 1 by 4, that is 1 by 4. So this t is equal to 1 by 4 divided by 200. Okay, so you will get 1 by 800 second. So what is 1 by 800? What is this value? Can someone tell? Please use a calculator and do this. What is the value here? It is 0.003. So this point will be 0.003. Okay, and what is this point? Can someone use the same logic and find this value? How can we find this value? So you can see that why again this become 0 when this circle, when this point is come to this point. Okay, this point. So at that time it is totally 5. Okay, so what you have to do is to find this value, you have to equal this whole terms to 5. Okay, so you will have to, sorry, 5 is equal to 5 ft plus 5 by 4. Then you can find the t here. Okay. So what is the value here? 5, 5, 5 cancel out. Okay. Then you will get 1 is equal to f is 100. So we have 200t plus 1 by 4. Okay. So then t is equal to 1, that is means 3 by 4 divided by 200, that means 800. So what is the value here? 3 by 800, no? That means 3 times this, 3 times this, that is 0.009, this point. In the same manner, try to find this value and try to find this value. To find this value, what you have to do? So it is a minus peak. So that means the point should be come to here. Okay. So that means it is 3, 5 by 2. Okay. So this value is, so this total angle is from here to here, it is 3, 5 by 2. So you have to equal this whole terms to 3, 5 by 4, and you have to find the t. Okay. Then what is this point? This point means this should be come to here. This should be coming to here. This should come to here. This point should come to here. That means total you have whole this circle, whole this angle is 2, 5. No? 2, 5. So you have to do to find this point, you have to equal all this equal to 5, then you can find the t. So try to find this value and this value. Okay, this value and this value. So we can verify it. Okay, so we will see. Let's go to the MATLAB. So I don't know whether your exam is online or not. Okay, but last time the exams are online. Okay, so a student can use the MATLAB. Okay, so when they are given this type of question, they use the MATLAB and just plot it and just copy. Okay, so anyway, I have to give the full marks for them. Okay, but this time I don't know. It may be a physical exam because now the situation is good. No, there is no any pandemic situation. So maybe this is a physical exam. Okay, so you can't get any help from MATLAB at this time. Okay, but last year student I think has got full benefit from MATLAB. Some, not all. Okay, so anyway, try to answer. Meanwhile, I will put this. I put this graph in the MATLAB and see what is we get. So in next question, they are asked, we have to add these two signal. Okay, we have to add this two signal and we have to form another signal, composite signal. We call it a composite signal. That means adding two sinusoidal signal. Okay, so you are asked to draw the waveform. Okay, before next week, try to draw this. Okay. So maybe you can't do this one. Okay, please try to do. Please try to do this using that periodic. So I'm going to use MATLAB. Okay, can you see my MATLAB screen? Can you see my MATLAB screen? I hope you can. Okay? So we will start. So we know that. So here from this editor window, we can type our script and run. Okay, and also we can write the command here at the command window, and uh, we can the same thing we can write here, and we can run them one by one. But normally I am used to do like this. Okay, I just write the script and run and get the value. Okay, so I will use the same thing. Okay, so normally I use this first command. I think hope you can remember what is this. CLC clear all means we are going to clear all the workspace variable. Okay, so we had one MATLAB session, but it is not successful. No, anyway, we will so try to understand at this point also. Okay, so now so my independent variable is t, so now I am going to define t. Okay, so I am going to define t from 0 to 0.001 step to 1. Okay, so so you can see that uh, this is one way to define a vector, define array. Okay, so if you have run this, okay, if you have run this, you have to save the file. Okay, so Sine or something. Okay, then you can see that we had some t value. Yeah, I'm sorry, I didn't put the. So what is the wrong with me? Here I get only two values, 0 and 1. For this t, it is array, no? I have only 0 and 1. So what is the mistake I have done? I didn't put the decimal point here. Okay. So I will point here, then I will run it. So you can see now we have generated array. Okay. So this is the in variable window. You can see the variable. So we have 0, 0.001, 0.002, 0.003, like that up to 1. Okay, up to 1 you will get. So we have some array, no? Okay, we have array. Then we can find, now we have defined our independent variable. Now we can write our expression. Okay, so we have v is equal to 3. So you have to use the multiplication operator every time, that is star. Okay, so we have sine. Okay, 2, we have to put multiplication. So 5 is like this, 5. F is 100, no? 100 t plus 5 by 4. This is our signal, no? This is our signal, no? Okay, so let's look it again. So it is 3. You have write it. Yeah, yeah. It is 3 sine 2500 t plus 5 by 4. Okay, so that is okay. Okay, then I have to, now I have, so if I run this, you can see that t is here, no? So so this key value will substitute here, and it will automatically calculate the corresponding value, corresponding voltage value, no? Okay, so you will get same size array. So here you will get the voltage value. Okay, so so this function will automatically generate array, because here this t is there and this t is there. So the different value, so it has 1001 value. Okay, so all that 1000 value will substitute here one by one. Then he calculate the v, the matlab calculate the v, then it generate another v vector. So it is again 1001 element, no? It is with again 1001 element. Okay, so now we have to plot it, no? We have to plot. So it is x, that means independent variable with respect to t. Okay, so if I run this, plot t with undefined function, sorry, this should be capital, no? I think it is okay. So we can't see it, so we have to reduce this size. I think if we reduce it to 0.3, I think that is enough. This is still not visible, no? So I will 0. 0.1. Zero point zero one, but I have to put more value here. Put a small step here. It is now okay. No? So to get 2 more, I will put it as 2. Yeah, I think this kind of one we have to get. Okay, if we on so you can see that this point we get is that what is that this point? It is 0.003. No, this point should be 0.003. So we have a mistake. No. Is this correct? 1/800 is 1/800. What is the value? So I will use the matlab. So that is 1/800. No? It is 0.0013. No? No, it is 0.0013, not 0.003. I think I have. Yeah, we get some wrong value here. So anyway, this should be 1. Okay, it is 0.001. This is 1/800. This point is 0.0013. Okay, this point, and this point should be 3. No, it is 3 times. That means 0.0039. 0.0039. Okay, so this point. So let's take this point. So you can see that it is correct, no? 0.0013. That means it is less than 0.2. Okay, and this point is not this point actually. This point. Okay, this is the 0% point. It should be 0.0039. That is less than 4. No, so I think these values are correct. Okay, so these values are correct. No, okay. So you can see that if we draw a composite signal, okay, that means if I will quickly tell using the MATLAB. Okay, so now this is for one signal. Okay, in next section we are asked to draw the composite signal. That means we have to add 2 signals together. Okay, so what is our first signal? We get, as I can remember, it is 2 sine 2 5. If is 50, no, we get 50 p, and we get 0 phase shift. So this is our first signal. No? So this is our first signal, and this is our second signal. So according to your question, this is the signal generating from first turbine, and this is the signal generating from second turbine. So we add these two signal together. Okay, we add these two signal together, and we have to draw the composite signal. So you can see that it is like this. No? So is this a sinusoidal signal or not? This composite signal is a sinusoidal signal or not? Can anyone tell quickly? Make a sinusoidal signal එකක් නැත්. ටක් ගාලා yes or no කියලා ගහලා ඉවන්න. Please quickly type yes or no, because we have only 6 minutes remaining. Is this a sinusoidal signal or not? So if you get some more value here, is this a sinusoidal signal? This is not a sinusoidal signal. No? Sinusoidal signal should be like this. This is not a sinusoidal signal. Okay. And in next question, okay. So you are asked, draw it. Is it a sinusoidal wave? So it is not a sinusoidal wave, no? So suggest a method how to make the composite signal to be sinusoidal. So this should be to be sinusoidal. So how can anyone tell how we can make this sinusoidal? How we can make this composite signal? So now it is not a sinusoidal signal. So can anyone tell how? So maybe you couldn't answer the question, but do you have any idea? So I will give you a clue. If we can change the phase of one signal, if you can change the phase of one signal, we can make this composite signal sinusoidal. So what you have to do, what we can do? If we change the phase of one signal, we can make it as a sinusoidal signal. The composite signal can be made as a sinusoidal signal. So what we have to do? Can anyone tell? Yeah, actually, so you can see that. Okay, you can see that. So this is not a sinusoidal signal. Okay, so that means what is happening is, okay, so we have one signal like this. Okay, we have one signal like this. So I will draw the two signals separately. Okay, please try to understand this. Okay, so these are will be very beneficial. Okay, so if I will plot this as V1. Okay, so this is my first signal. Now I just delete this. Okay, and I plot V2. This is my second signal. This is the first signal generating from the first turbine, and this is the signal generating from the second turbine. Okay, so if I plot them separately, so plot TV1, and you have to write the hold on here. You have to type the hold on. Okay, then you can use the same command, plot T V1, V2, sorry, plot T V2. Okay, so if you so now you can see we have two signal, no? So this is our second signal, the high amplitude signal, and you can see it is 100 hertz. Okay, 100 hertz. That means this is a 50 hertz. That means this the blue line frequency is much higher, actually twice than this one. Okay, so you can see that composite signal, if we write the composite signal, so that means the added, this value should be added. So this one and this one should be added, and we get one value. And this one and this one should be added, we get a. So we have to add these all points. Okay, from this signal and this signal we have to add. Then we will get some another signal. Okay, so what if have this in same phase? Okay, so what happens if they are in same phase? For example, I will write it here. Okay, so one signal is like this. Sorry. So one signal is like this. Okay, another signal is like this. Okay. Okay. So if you get the composite signal, you have to get this both adding value. Okay, so it will become like this. Okay, it is like this signal you will get, no? It is on the sinusoidal signal. You can see it. Okay. But what if this is the case we get? Okay, and what if we have two sinusoidal with in the same phase? Okay, so here we have one sinusoidal signal. Okay, and here we have one sinusoidal signal. No, actually for this signal we can't use the we can't make it simply sinusoidal. Okay, by changing the phase also. By changing the phase only we can't make it sinusoidal because frequency are changed. So we have to put phase and also the frequency same. Otherwise you will not get a sinusoidal signal. Okay, because here also we after we add, because these are in different frequency, they will add in different value. So it also will generate a non-sinusoidal signal. Let's see it. Okay, let's see it. Okay, so if I put the same phase here, okay, if I put the same phase here, pi by 4, it will not generate a sinusoidal signal again, I hope. Okay, so here equal V1 plus V2. That means our first signal and second signal. Okay, and we have to plot that one. No? Plot T V1. That means V. That means our composite signal. Okay. So if we have run, so you can see that this yellow color, this green color one is a composite signal. So it is also not a sinusoidal signal. No, it is also not a sinusoidal signal. So if you are not clear, so if I remove this 2, okay, if I remove this 2 by put in command by converting them into command. So this is also not a sinusoidal signal. So to do the sinusoidal signal, we have to make the phase and frequency same. Okay, and we have to do the frequency also. Then we should get the sinusoidal wave. Okay. Now you can see that we will get the sinusoidal signal. Okay. So we have to make the phase and we have to make in phase signal with same frequency. So if you don't have the in phase signal, so it will also not generating if although the frequency is same, if the phase are different, it will not generate a sinusoidal signal. No? It is generating a sinusoidal signal. No, it is not with the phase. No. Yeah. So, so at first time I thought that if we change the phase, we can get the sinusoidal signal. Okay, sinusoidal signal. But it is not depend on the phase actually. It is only depend on the frequency. Okay, so we have to make the frequency same for both signal. Otherwise, we can't generate a composite signal as a sinusoidal signal. So you can see that here, if we have like this, and if you have another one like this, if the phase shift is there, so anyway, it is generating a sinusoidal signal. The frequency are same, so you can use, you can see, so you can please try to, I will send this to chat. Okay, so you can paste it MATLAB and you can analyze further. Okay, by changing the phase, whether you will get a sinusoidal signal or not. Okay. Okay, I have sent that code. Please copy it and try to plot. So try to change the phase and try, please try to see what happened. Okay, and try to understand it. So I hope it is enough to draw the signal. Okay, so anyway, before the next class, I will record this one. Okay, today I will try to record this one. This is because this question you can't do. I hope you can't do by yourself. Okay, you need my help. So I will do this one, this two. Okay, and we will try to do some question in next week also. Okay, and please submit that assignment. Okay, please try to answer the assignment and try to submit it. So I hope okay, so let's stop the today session. But before stopping, so do you have any issue? So still we are at the beginning. Okay, when we are going further, so it will be more difficult. Okay, so I think if you can clarify your doubts here, it is very beneficial for you. Okay, so if you have any problems, මොනවා හරි ප්‍රශ්න තියෙනවා ඔකට තේරෙනවද සබ්ජෙක්ට් එක සාමාන්‍යයෙන් ඔළුවට වැටුණාද මේක මේවා ගැන තමයි අපි කියන්නේ සබ්ජෙක්ට් එකේ අඩුම තරමේ කියන්නේ සබ්ජෙක්ට් එක ගැන අයිඩියා එකක් ආවද අඩුම තරම Yeah, thank you. If you get the idea about a subject, it is at this moment it is okay, okay, because if you can't do some mathematical things, it is okay. I can accept it. I can bear it. Okay. If your mathematical calculations are wrong, I don't consider it actually, because we are not going to do the maths here. Okay. We are learning signal and system. So I want your understanding about six signal and system. Okay, how to analyze them, what is the procedure. Okay, so if you have done any mathematics error, I don't care about it. Okay. Uh, so anyway, try to do this type of question by yourself. Okay, and it will improve your mathematical knowledge also. So it is anyway, it is beneficial for you. Okay, because if you are going for higher studies, you you have to have that knowledge. Okay, otherwise you can't continue. So මොකද ප්‍රශ්නයක් නැත්නම් අපි නවතිමු. ඔකටට මොනවාරි කියන්න තියෙනවා නම් කියන්න. හරි. නැත්නම් ලීව් වෙන්න පුළුවන්. මම විනාඩි 5ක් විතර ඉන්නවා. කට්ටියගේ ප්‍රශ්න මොනවා හරි තියෙනවා නම් අහන්න. ප්‍රශ්න නැත්නම් කට්ටිය ලීව් වෙන්න. ප්‍රශ්නයක් නැහැ. So I will be here another 5 or 10 minutes. So if you don't have any question, you can leave. Okay. So if you have any question, you can ask. You can raise.